right, we're finishing up 3.1 today. So we need to go over a few definitions to start, and you have this in your Google Doc. So turning points are the points where the function values change from increasing to decreasing or decreasing to increasing. So basically, these are the points where the function, where the graph switches direction. And then your minimums, these are going to be your low points, the valleys of the graph, you could say. So this turning point is lower than any other point around it. That would be your minimums. And then your maximums will be the high points or the peaks of the graph, where the turning point is higher than any point around it. And then finally, X-intercepts, that's a term we know. X-intercepts are the points where the graph crosses over or intersects the x-axis. So your learning target for today is I can determine the key features of the graph of a polynomial function. So to do this, you're going to first graph the polynomial. So look at number 1. We're going to do this number 1 together. You would put that into Desmos or into your graphing calculator. And then you're going to give these 4 key things. So turning points, minimums, maximums, and x-intercepts. So let's try that now. Let's go to Desmos or use your graphing calculator and put in number 1 there. All right, so you would put it in and it looks like this. All right, so turning points. Let's count the turning points. So the turning points are where the graph changes direction. So notice the graph is going up, and then at this point right here, it turns and it goes down. Then at this point here, it turns and it goes up. And then this point here, it turns and it goes down. So there are 1, 2, 3 turning points. So that would be the first thing you write, 3 turning points. And then we'll give the x-intercepts. So the x-intercepts would be right here. And you would write this point, negative 2.57, comma 0. And then there's another one over here, 2.57, comma 0. So 2 x-intercepts. And now let's give the minimums. So the minimums are the low points. So this is the low point. This is what you might call a valley. So the minimum point is 0, 2. And then there are 2 maximum points. One and 2. So we would put those 2 points there for maximum points. All right, so I'll show you, see if you could see this, but that's what the answer would look like there. So 3 turning points, your minimum, your 2 maximums, and then your 2 x-intercepts. So that's what you're doing here. So go ahead and finish up into number 10. And now let's go over the applications. Okay, so applications, scroll all the way down where it says applications here. Let's do one together and then you'll do the other one on your own. After X hours of hiking, Nadia's elevation is, and then you get that equation there in meters. After how many hours will Nadia's elevation be 15 meters below sea level? So X hours, so X stands for time. And that's what we're trying to find, how many hours. So we need to solve for X. So to do this, you're gonna plug in this equation in for your first equation in Desmos. And then your second equation will be given by this 15 here. So 15 meters below sea level means this is going to be a negative 15. So let's see what that looks like in Desmos. All right. All right, so over here I have my first equation just exactly as it was given. And then we said it's going to be negative 15 because it's below sea level. That makes it negative. And then remember, when you're doing a constant in Desmos, you have to put in that 0x or else it won't graph properly. So 0x minus 15. And then you will get something that looks like this. And your answer, remember, we're looking for x. So we're looking for the x value. Your answer is the intersection of the two right here. And the x value of this intersection is 6.8. So that means it took 6.8 hours. And that would be your answer, 6.8 hours. All right, that's the lesson for today. Go ahead and finish up that worksheet and turn it in to Google Classroom.